Okay, so for today's lesson, we're going to go through a review on trig values. So before we get into some examples, let's just kind of review ourselves on evaluating trig functions and what that looks like. So let's look at how we evaluate trig expressions is we'll find the reference angle, and then from that reference angle, we will create our ratio. So this is the reference angle right here. It's always that angle that sits against the x-axis. The side length that is opposite, that angle is what we'll use for the opposite length. And then the leg that is adjacent will be our adjacent side. And then this is a right angle, so that side opposite the right angle is our hypotenuse. With the trig values, we have 6 different ratios we could make. Remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. These are the reciprocal functions. So to go from sine to cosecant, we just flip that ratio. Cosine to secant, we just flip that ratio, and same thing with tan to cotan. So, reviewing the 2 special right triangles that we're going to be using. We have our 30, 60, 90. Across from 30 degrees is 1. Across from 60 is square root of 3. And then the hypotenuse is 2. So we need to also remember radians. So 30 degrees is going to be our pi over 6. And then 60 degrees is the pi over 3 in radians. For the 45, 45, 90, the legs are both 1, and our hypotenuse is square root of 2. Pi over 4 is the radian form for 45 degrees. Okay, we can then have quadrantal angles. These are angles that fall on the axis. You don't have a reference angle, so here we have to use the different ordered pairs. So for these, we are going to be using x and y instead of opposite and adjacent. So to create, this would be x comma y. And so sine always goes with y and cosine always goes with x. Remember, this is our starting point 0, and then up here is 90 degrees or pi over 2. This is 180 degrees, which is pi in radians, 3 pi over 2 in radians, or 270 degrees. And then all the way back around is 360 degrees, or 2 pi. Okay, so let's get into some examples. So for these, it says find the exact value of each trig function, draw a triangle for each. We're going to draw a triangle or a point if it's a quadrantal angle. Okay, so for number 1, this says cosine of 3 pi over 4. So the first thing we do is construct this angle. So if I were to place 3 pi over 4, that is going to fall in the second quadrant because I start here and I'm going counterclockwise to land right there. This reference angle is pi over 4. So using those special right triangles, we label our triangle. Now remember, if your triangle falls outside of the first quadrant, one or both legs will be negative. So this leg sits in the negative x, so that is a negative 1. Okay, now that we've constructed our triangle, I now look at the fact that I'm evaluating cosine. Cosine is adjacent over hypotenuse. So the adjacent side is negative 1 over the hypotenuse is square root of 2. We have to rationalize the denominator of our ratio, and I get negative root 2 over 2. Okay, example 2. Just like we did before, we are going to construct this angle. 7 pi over 6, if I convert that to a mixed number just to help us place this, that is 1 and 1/6 pi. So 1 pi lands us here. So then we just go 1/6, and we fall in the third quadrant with the reference angle of pi over 6. Opposite pi over 6 is 1, the other leg is √3, and then the hypotenuse is 2. Both of our legs are negative because this falls in the negative x and this falls in the negative y. Cosecant is hypotenuse over opposite. So our hypotenuse is 2. The opposite side is -1. 2 divided by -1 is -2. Okay, tan of pi over 3. So if I construct pi over 3, that falls in the first quadrant. Our reference angle is pi over 3. √3, 1, and 2. Now, everything's going to be positive because it's in the first quadrant. Tangent is opposite over adjacent. So the opposite side is √3. The adjacent side is 1. So we're just looking at √3. Okay, let's keep going with some more examples. Okay, so for number 4, tan of pi over 2. This is a quadrantal angle. This will fall right here. And that ordered pair is 0, 1. So if we were to travel to this point, we don't travel it all along the x, and we go up 1 for the y. With quadrantal, for tangent, we're using y over x. So this is my x, that's my y, so y over x. You cannot divide by 0. So if you have 0 in the denominator, we say undefined. When we are evaluating trig values, we use undefined, not no solution. No solution is what we use when we're solving an equation and that we cannot solve. So we say undefined here. Okay, number 5 is secant of -11 pi over 6. So the negative angle tells me I'm going clockwise instead of counterclockwise. So 11 pi over 6, that's 1 5/6 pi if you want to think about it in a mixed number. So negative pi, 5/6 pi, we fall right here. And I have a reference angle of pi over 6. Labeling my triangle. Secant is hypotenuse over adjacent. So the hypotenuse is 2, adjacent is √3. Rationalize the denominator. 2 √3 over 3. Okay, we have 2 more quadrantal angles. So sine of pi. Pi falls right here. That ordered pair is -1, 0. Sine is all about the x since h is 1. I'm sorry, sine is all about the y. So our y value here is 0. So it's just 0. Secant of negative pi. Well, negative pi, we land in the same spot. So cosine is all about the x. So this is going to be the hypotenuse over x. The hypotenuse is always 1, and here our x is -1. So 1 divided by -1 is -1. Okay, and that's it for this lesson.